Graph the function and give its domain and range. F of x equals the square root of x plus 6. First, we'll find the domain by noting that the radicand must be non-negative. Therefore, x plus 6 must be greater than or equal to 0. And so x must be greater than or equal to negative 6. So the domain of this function is the interval from negative 6 to infinity, including negative 6. Now we'll create a table of values in order to graph. So we'll choose values of x and find corresponding values of f of x. When x is negative 6, f of x is the square root of negative 6 plus 6, or the square root of 0, and so it's 0. If x is negative 5, then f of x is 1. If x is negative 2, then f of x is 2. And if x is 3, then f of x is 3. So we purposely chose values of x such that f of x will be an integer. Now we can use these points, plot them on our graph in order to graph the function. To do this, let's first label our coordinate grid. We'll let each dotted line represent 1 unit. So the minimum on each axis is negative 6, and the maximum on each axis is 6. We'll plot our first point, negative 6, 0, by finding negative 6 on the x-axis. We then have a point negative 5, 1. From the origin, we move left 5 units and up 1 unit. We have the point negative 2, 2. So from the origin, we move left 2 and up 2 units. And we have the point 3, 3. So from the origin, we move right 3 units and up 3 units. We'll then connect these points with a smooth curve, showing that the graph continues indefinitely to the right, but does not continue indefinitely to the left, because remember that the domain is from negative 6 to infinity, including negative 6. So our range is the interval from 0 to infinity, including 0. Notice that the graph of f of x equals the square root of x plus 6 is shifted 6 units left compared to the graph of y equals the square root of x.